this ether? Common name. IPSC name though we have discussed. What will be the common name? I taught you how to name it. So we have a tertiary butyl group and a methyl group. We have a tertiary butyl group and a methyl group. Okay, so it is also known as tertiary butyl methyl ether. It is also known as tertiary butyl methyl ether. Now, today we shall discuss how does this reaction occur when these are treated with halogen acids like this. Okay, so when one of the alkyl group is tertiary, how does the reaction occur? Now, out here, just note down one thing. Note down one thing. Okay. Note down one thing. Okay. The tertiary alkyl group. The tertiary alkyl group, or listen very carefully. The tertiary alkyl group or the group which forms a stable carbocation, which forms a stable carbocation. Okay, the tertiary alkyl group or any group which forms a stable carbocation forms a bond with halide ion, and the reaction proceeds by which mechanism now? SN1 mechanism. Hey, by the way, did I discuss the reactions of ethers when both the alkyl groups are primary? Did I discuss that thing? And now I'm getting confused. I think I discussed that with another batch. Okay, so let us discuss the reaction of ethers with halogen acids. Okay, let us discuss the reaction of ethers with halogen acids. So halogen acids means it can be HI, it can be HBr, it can be HCl and so on. Okay, so not HF, so HCl, HBr or HI. Now how do ethers react with halogen acids? Okay, so let us see. Now we know the ethers, okay, they have a lone pair of electron on oxygen atom. They have a lone pair of electron on oxygen atom. So whenever they are treated with halogen acids, what will form? One of the alkyl group will form a bond with halide. So we get a alkyl halide like this. We get an alkyl halide. Okay, one of the alkyl group forms a bond with halogen, and the remaining part, RO part, forms a bond with hydrogen, and we get alcohol like this. We get alcohol. So what happens when ethers are treated with halogen acids? When ethers are treated with halogen acids, okay, what do we get? We get a mixture of alkyl halide and alcohols. We get a mixture of alkyl halide and alcohols. Okay. Now let us see some examples. So note down one thing. Now, when the alkyl groups are same, the ethers are called symmetrical ethers. So, what are symmetrical ethers? When both the alkyl groups are same. But when the alkyl groups are different, when the two alkyl groups are different, the ethers are known as your unsymmetrical ethers. Okay. Now, if the two alkyl groups are different, so remember what happens? So if the two alkyl groups are primary, when the two alkyl groups are primary, means when both the alkyl groups are 1 degree, then what happens? Then in this case, the smaller, remember the smaller alkyl group forms a bond with halide. The smaller alkyl group forms a bond with halide. Okay, and the reaction occurs by, remember, and the reaction occurs by SN2 mechanism. And the reaction occurs by SN2 mechanism. Okay, so you just need to remember this. So what have we discussed? When both the alkyl groups are primary, okay, and when it reacts with halogen acid, then which alkyl group forms a bond with halide? Remember, the smaller alkyl group, means the alkyl group containing lesser number of carbon atom forms a bond with halogen. So the bigger alkyl group, okay, it forms here, it produces here alcohol like this. It produces alcohol. Okay. So what does this mean? Let us see now. Let us see. Okay. And remember, the reaction proceeds by SN2 mechanism. Okay. And always remember the fact that the smaller alkyl group, it forms a bond with halide. The smaller alkyl group forms a bond with halide. But you need to remember this one. So when does this happen? This happens when both the alkyl groups are primary. Okay. Now, as for example, suppose I take this compound, dimethyl ether, or what is the IUPAC name? Methoxymethane. It's methoxymethane. So what happens when I treat this with HI now? What happens? Yes, someone please tell me the answer. What happens when methoxymethane is treated with HI? Now you'll say, sir, here both the alkyl groups are of the same nature. Yes, both the alkyl groups contain the same number of carbon atoms. So yes, any one of the alkyl group forms a bond with halide. One methyl group forms a bond with halide. So we'll be getting methyl halide. Okay. And the other alkyl group, along with this oxygen, it forms a bond with hydrogen. The remaining part, alkoxy CH3O, forms a bond with hydrogen, and we get methyl alcohol like this. We get methyl alcohol. Okay, now if in the question, so you have discussed the simplest reaction, both the alkyl groups are primary and both the alkyl groups are of the same nature. Now here I'll just make one small modification. Here I'm going to write down excess of HI. So here HI is not in excess. Here I have taken excess of HI. So what happens out here? Again, both the alkyl groups are of the same length. So one of the alkyl group forms a bond with halide like this. Plus the other we get CH3OH. Now HI is in excess. HI is in excess. So obviously what is going to happen? One of these products will react with excess of HI. Now, so from the chapters we have learned, okay, so now you tell me, out of the two products, which one will react with excess of HI? Is it methyl iodide or methyl alcohol? Which will react with excess of HI? Tell me. Pratyek, yes, bolo. Which one is going to react with excess of HI? We have two products, methyl iodide and methyl alcohol. So out of these, one is going to react with excess of HI. So which of this product will react with excess of HI? We have done in the alcohol chapter. We have done this in the alcohol chapter. So alcohols, yes, they again react with halogen acids to produce methyl iodide again. So with excess of HI, one of the product will be methyl iodide and the other, as expected, methyl alcohol. But the alcohol will react with excess of HI again to give you alkyl halides like this. Okay, so these are going to be the final product with excess of HI. Fine. So now this was the simplest case. So just let me increase the difficulty level of the question. Okay, so now we have a very important point in our hand, that if the two alkyl groups are different and both the alkyl groups are primary, then obviously what will happen? The alkyl group containing lesser number of carbon atom, means the smaller alkyl group forms a bond with halide. The smaller alkyl group forms a bond with halide. Okay. So let us solve some more questions now. Okay, fine. So do this on your own now. CH2, CH3. Okay, so reaction with HBr. Reaction with HBr. Now what is going to be the product? What now? Both the alkyl groups are primary, fine, but the alkyl groups are also of different nature. One of them is a methyl containing one carbon, the other is ethyl containing two carbon. So yes, what is the rule? If we apply the rule which we have
Methyl
written,
bromide plus ethyl alcohol.
yes, the smaller alkyl group forms a bond with halogen. So which is the smaller alkyl group? Methyl. So the methyl part forms a bond with halogen, and the remaining alkoxy part combines with hydrogen to form alcohol. Now if HBr is given in excess, then if HBr is given in excess, then the alcohol will react with excess of HBr to give you ethyl bromide again as the final product. Okay, so it's so easy. It's so easy. Okay, so we can easily predict the product. Okay. Now what happens when anisole OCH3 reacts with HI? So do this. So what is the common name of this compound? The common name of this compound is anisole. The common name of this compound is anisole. So what happens? Just tell me. What do we get? What are the final products? Yes, yes. Please tell me. So which is the smaller alkyl group? Methyl. Yes. So methyl part forms a bond with halide. And the remaining part, a phenoxide part, it forms a bond with hydrogen, giving us phenol. So very important question. How will you convert anisole to phenol? Okay, how will you convert anisole to phenol? So anisole can be converted to phenol by treating with halogen acids like this. Okay. So one more. Chalo. So predict the product now. Again, this is a primary alkyl group. The carbon attached to oxygen is a primary carbon. So both are primary alkyl groups. Okay, so don't think it's secondary. So the carbon attached to oxygen is primary. So here again, smaller alkyl group is methyl. Fine. So methyl forms a bond with halide. Plus we'll be getting CH3 from, if I start from here, CH, CH3, CH2, OH. Plus we get this. Now you can easily do it. Okay, there should not be any problem. Okay, so when both the alkyl groups are primary, then remember the smaller alkyl group forms a bond with halogen. And yes, what did we say? The reaction occurs by SN2 mechanism. So let me just discuss a bit about the mechanism since it is there in your syllabus. Okay, so we have said that the reaction occurs by SN2 mechanism, and SN2 mechanism that we know: attack of nucleophile, loss of leaving group, it occurs at the same state. Okay, so let us discuss the detailed mechanism about this. Okay, so let us of this reaction. So if you don't understand anything, please let me know. So mechanism. Now, all halogen acids, okay, they are protoic acids. So that means they dissociate in aqueous solution to give us H positive ion and Br negative ion, or any halide ion. So I'm just going to write an X negative out here. It's X. I'm going to write an X negative. Okay, HX. I'm going to write an X negative out here. Okay, so what happens? How does the reaction occur? Now let us see. Now CH3O, CH2, CH. So yes, what do you think will happen in the first step? Now you should have an idea. Eh? Yes, who can give me the answer? What do you think should happen in the first step? So HX dissociates to give you H positive and X negative. So what do you think will have in the what do you think will happen in the first step? Yes, any guesses? You should be knowing this. Oxygen में lone pair of electron है. Proton release कर रहा है. So what will happen? There will be protonation of the ether like this. Eh? Okay. So this oxygen through its lone pair will form a bond with this proton like this. Protonation. Alcohol में हुआ था ऐसे ही हो रहा है. So what do we get out here? We get CH3O. Now oxygen contains a positive charge CH2 CH3. Now we have said that the reaction takes place by which mechanism? SN2 mechanism. Okay, now which part will act as a nucleophile? Yes, tell me, which part will act as a nucleophile? Which part will act as a nucleophile? So we have halide ion out here. Okay, so what happens out here? The halide ion which was formed in the first step will act as a nucleophile. Right? Now we know the order of reactivity towards SN2 reaction is determined by steric hindrance. Right? We have learned that in details. So in SN2 mechanism, always remember the nucleophile will attack less sterically hindered carbon atom. In SN2 mechanism, the nucleophile will always attack the less sterically hindered or less congested carbon atom. Okay, so this carbon is bonded to 3 small methyl groups, whereas this carbon is bonded to 2 small hydrogen and 1 big methyl group. Right? This carbon is bonded to 3 small hydrogen atoms. Very less steric hindrance, very less congestion. Whereas this carbon is bonded to 2 small hydrogen and 1 big methyl group. So compare the steric hindrance. If we compare the congestion at this methyl is far less than this ethyl group. Right? So there is less steric hindrance out here due to the presence of 3 small hydrogen. So obviously, as far as SN2 mechanism is concerned, this nucleophile will attack the sterically hindered, less sterically hindered carbon atom like this. Okay, attack of nucleophile. So what must happen again simultaneously? SN2 में क्या होना चाहिए? Attack of the nucleophile तो चलो किया. What must happen simultaneously? क्या होगा yes SN2 में? चलो 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 बताओ SN2 में attack of nucleophile होगा then simultaneously what is going to happen? Attack of the nucleophile and loss of leaving group. So what is the leaving group out here? These oxygen contains a positive charge. So in order to neutralize the positive charge, these 2 electrons will go out here. These 2 electrons will be transferred to the oxygen. So ultimately this carbon oxygen bond is broken. So what do we get out here? What is the product? देखो तो what is the product? The smaller alkyl group forms a bond with halide plus okay the other alkyl group forms here alcohol part like this. The smaller alkyl group forms a bond with halide. So the product are alkyl halides and here alcohol. So this is how the reaction occurs, right? But this mechanism is valid when is this mechanism valid? This mechanism is valid when both the alkyl groups are primary. Remember, this mechanism is valid when both the alkyl groups are primary. So these are the steps. Okay, so this is how the reaction of ethers occur, right? Okay, so now turn to the earlier thing which we have written it down. Okay, so let us now refer to the earlier topic. Now, fine, when both the alkyl groups are primary, then it is not an issue, right? Okay, so now we know that if questions do come in the exam, then just remember both alkyl group primary है तो क्या करोगे? यह smaller alkyl group को तुम halogen के साथ bond कर दोगे. Okay. Now, if the alkyl groups are secondary or tertiary, right? Okay, so what have we written earlier? What had we written? Okay, second, what had we written earlier? What had we noted down? So we had noted down that if the alkyl groups are tertiary, if the alkyl groups are tertiary, okay, or those groups, whatever group which forms, or those groups which forms a stable carbocation. Okay, if the alkyl groups are 3 degree, or those groups which forms a stable carbocation, then these groups, whatever groups, these groups means 3 degree or those which forms a stable carbocation, then these groups, it forms a bond with a halide ion, and the reaction now occurs by SN1 mechanism. And the reaction now occurs by SN1 mechanism. Okay. Now what does this mean? What does this mean? So दोनों ही primary alkyl group है तो we'll refer to the earlier. Smaller alkyl group forms a bond with halide. But now, what if the alkyl group is primary and one of the alkyl group is tertiary? As for example, say we have methyl tertiary butyl ether. We have methyl tertiary butyl ether. Methyl tertiary butyl ether. Okay. Now, if these are treated with halogen acids such as HI. Now, what have we written? If the alkyl groups are 3 degree, yes, we have a 3 degree carbon outage, is a 3 degree alkyl group. Then in this case, the tertiary alkyl group forms a bond with halide. So what do we get? We have a tertiary alkyl group like this. We have a tertiary butyl group. In this case, the tertiary butyl group forms a bond with halogen. Right? So remaining part, CH3O part, forms a bond with hydrogen, giving us methyl alcohol. It forms a bond with hydrogen, giving us methyl alcohol like this. Very simple. And the reaction occurs by SN1 mechanism. Now let us see how does the reaction occur. How does the reaction occur? Let us see how does the reaction occur. Okay. Now the first step is going to be the same. First step is going to be the same. So same means here we have HI. Again it dissociates to give us H positive and I negative. Okay, so let us see out here how does the reaction occur. So CH3O, we have a lone pair C. Again, what do you think should happen in the first step? Again, there is going to be a protonation. The proton will attach itself to the oxygen like this. Okay, there will be a protonation like this. So we get this. Okay, now first step is absolutely same as the earlier one. Now there is a difference. Now there is a difference. Now we know what is the order of stability of carbocation. What is the order of stability of carbocation? You should be knowing this. You should be knowing this. What is the order of stability of carbocation? 3 degree carbocation are very stable, followed by 2 degree, followed by 1 degree. I also discussed carbocations are stabilized by resonance. Benzyl carbocation, they are really stable. So any carbocation which is resonance stabilized is very stable. Okay. So now if the bond cleavage occurs out here, if this bond breaks out here, then a tertiary carbocation will be formed, which is very stable. And if the bond breaks out here, a methyl carbocation will be formed, which is very unstable. So what happens? Now, cleavage occurs in such a way. The bond breaking occurs in such a way that it forms a stable carbocation. Okay. So, यहाँ का जो दो इलेक्ट्रॉन है ये ऑक्सीजन ले लेगा to neutralize the positive charge. So, bond यहाँ break होगा. Why does the bond break out here? To give a stable carbocation. So, what will be formed out here? देखो तो CH3OH, CH3OH. Fine. So bond is breaking out here. So what is formed out here? A tertiary carbocation is formed, which is very stable. A tertiary carbocation is formed like this. A tertiary carbocation is formed. Fine. Now, yes, we have a nucleophile out here. So obviously, very easy step. The nucleophile will attack the carbocation like this. The nucleophile will attack the carbocation, giving us the final product. So what is the product? CH3, CH3. So these are the final product. So this is how the reaction occurs. Okay, so ये तो हो गया. Okay, this is quite obvious. But here, from here, some the questions related to carbocation stability does come from here. Okay, so just you will be given predict the product. You have to predict the product. Okay, so yeah, so yes, we know tertiary butyl group which forms a very stable carbocation. So the group which forms a stable carbocation forms a bond with halide. Okay, what if I give you what is this group known as? What is this group known as?
Benzyl.
Benzyl. Very good. Benzyl methyl ether. Now, what do you think will be the product now? What do you think will be the product? Now, there might be a confusion. Okay, you'll tend to think that no, both the alkyl groups are primary. So methyl, the smaller alkyl group, it will form a bond with halide. You will tend to think. Okay, we tend to think in this way. Now, let us observe this question more closely. Now here we have a benzyl part, and we know if a benzyl carbocation is formed, this benzyl carbocation is very stable. Yes, have we discussed? Yes, it is very stable. We have discussed so many times. It is stabilized by resonance. So we have a group out here which is stabilized by resonance. And whenever the presence of such group, okay, whenever there is a presence of groups which is stabilized by resonance, then remember that particular group forms a bond with halide. So yes, we have a benzyl. Benzyl is very stabilized by resonance. Like here, a tertiary carbocation, tertiary butyl group, tertiary carbocation is stabilized by resonance. Here, benzyl carbocation is stabilized by resonance. So those groups which are stabilized by resonance, they form a bond with halide. So out here, what do you get? So benzyl, these forms a very stable carbocation. So these forms a bond with halide. So benzyl iodide, and what do we get? We get methyl alcohol like this. So mark this as important. Mark this as important. Okay. So those groups, we have written it down. Those groups, okay, if there's a tertiary alkyl group, then not an issue. But apart from tertiary alkyl group, those group which forms a stable carbocation. Okay, those groups which forms a stable carbocation will form a bond with halide. Okay, apart from tertiary group. So I'll give you one more. I'll give you one more. Okay. So this, I think you can do it on your own now. Now, what do you think will be the product and why? What do you think will be the product and why? So you'll tend to think again, you'll tend to think both are primary. Yes, we will tend to think that both are primary. Now, just you have to analyze. So, methyl, yes, it won't form a stable carbocation. But what about this allyl carbocation? What if a positive charge? What if the bond breaks out here and a positive charge is formed out here? With allyl carbocation, okay. So this carbocation, if this carbocation are formed, so if this carbocation are formed, if this carbocation is formed, then this carbocation again it's very stable. Why? Again, it is stabilized by resonance like this. The resonance stabilized hoga. If the bond, if the reaction occurs by SN1 mechanism, then this carbocation will be very stable as it is stabilized by resonance. Okay, so in such cases, what happen? Again, the group which forms a stable carbocation, such as this allyl group, it forms a bond with halogen. It forms a bond with halogen like this, and the other part forms alcohol. Okay, so remember, guys. So one short question is going to come from this topic. One short question is going to come from this particular topic. Okay, आएगा yes. Reaction of ethers with halogen acids. A question, minimum one question have to be based upon this topic. Okay. So is it understood or do I need to discuss? Okay. Achha. Now, if I just discuss this anisole, if I discuss electrophilic substitution reactions of methoxybenzene, or more commonly it is known as your anisole. Now, okay, so I have been telling you this time and again now. Okay, I have been discussing this time again. Now, this anisole, ये जो methoxy group है, OCH3 group, okay, is it meta-directing or ortho-para-directing? Is it meta-directing or ortho-para-directing towards electrophilic substitution reaction? Yes. कौन सा डायरेक्टिंग है ये? लास्ट क्लास में मैंने पूरा कॉन्सेप्ट क्लियर कर दिया था. Yes.
Orthopara.
क्यों?
Because of the presence of the lone pairs of electrons.
Because of the presence of lone pair. Very good. क्या होगा because of the presence of lone pair? Yes. Why? Lone pair है तो क्यों ortho-para-directing होगा? Yes.
Due to resonance, the
Good.
charges.
Excellent. Yes. Now you are bang on. Okay. So इसका resonating structure करोगे तो क्या दिखाई देगा? You will see that just as in case of phenols, you will see negative charge in the ortho and in the para position. That means these positions have high electron density. The electrophile will attack. Okay. Good. Very good. Okay. So now we know this is an ortho-para-directing group. And how do we come to know what is a simple technique I taught you? Any atom attached to benzene, if it contains a lone pair of electron, they are ortho-para-directing, and all the alkyl groups are ortho-para-directing. बस ये दो चीज simple याद करना. Okay. So now you write down the product. Okay, you write down the product. I'll give you some questions out here. I'll give you some questions. Okay. So the question goes like this. Write equations of the following reaction. Okay, write equations of the following reactions. Okay, so you have to write down the equations for the following reactions. Okay, you have to write down the equations for the following reactions. First, Friedel-Crafts alkylation of anisole, nitration of anisole, bromination of anisole, and Friedel-Crafts acetylation of anisole. So let me start with the first one. Okay. One, we have anisole. We know what is anisole. Okay, common name is anisole like this. So, Friedel-Crafts alkylation means what is the reagent you will be using? Chalo, what are the reagents we will be using in this reaction? Friedel-Crafts alkylation means what? What are the things we will be using? Friedel-Crafts alkylation में क्या use करेंगे हम लोग? What are the reagents we will be using?
Halobenzene. haloarenes with AlCl3.
Halo alkyl halides bolo. Alkyl halides. Which alkyl halide? Alkyl chloride. Okay, in
Alkyl
presence
chloride,
of anhydrous AlCl3.
AlCl3.
So, for example, I can use methyl chloride. Okay, in presence of anhydrous AlCl3. Now, what is going to happen? Which group will come in the para position and ortho position? Yes. So, yes, one of the alkyl groups will come in the para position, and the other product we get is where the alkyl group comes in the ortho position like this. Fiddlecraft's alkylation reaction means the introduction of an alkyl group by treating an alkyl chloride in presence of anhydrous AlCl3. And since this is ortho para directing group, the alkyl group comes in the ortho and para position. Okay, so 4-methyl anisole and 2-methyl anisole, and obviously this is going to be the major product. Okay, so number 2, yes, number 2, how am I going to write it down? Nitration means which group will you introduce? Nitration means nitro group. Very good. Yes. Now tell me what are the reagents to introduce a nitro group?
Concentrated HNO3 and concentrated H2SO4.
बस देखो सब चैप्टर में एक ही चीज तो रिपीट हो रहा है बार बार. कितना पढ़ रहे हैं और पढ़ना पड़ेगा. ये कॉन्क H2SO4 कॉन्क HNO3 बस. NO2 ग्रुप इंट्रोड्यूस होगा. ऑर्थो पैराडाइटिंग ग्रुप है. इससे इजी क्या होगा बोलो तो. नाउ one NO2 will come in the ortho position like this. Ortho nitro anisole. And yes, one nitro group will come in the para position, and obviously which is the major product again? The para product is the major product. Okay. Bromination. Bromination means introduction of bromine atom. So remember the fact that bromination out here, okay, just you need to remember this fact. The bromination out here occurs in acetic acid medium. It means acetic acid, it acts as a solvent. Okay, so just as in case of phenol, bromination was taking place in aqueous medium, it was taking place in carbon disulfide medium. Here, bromination occurs in acetic acid medium. Okay, so here what happens? One bromine again, it will come in the ortho position. One bromine will come in the ortho position like this. Okay, and the other bromine will come in para position. Again, para product is the major product. So last one, Fiddlecraft's acetylation reaction. What do you mean by this acetylation reaction? Fiddlecraft's acetylation reaction means introduction of an acyl group acid, introduction of an acyl group by treating with acid chloride. Okay, so let us take an acid chloride, for example, CH3COCl acetyl chloride. It's an acid chloride. Acetyl Fiddlecraft's acetylation means introduction of an acyl group in benzene ring by treating acyl halides in presence of again anhydrous AlCl3. Okay, anhydrous AlCl3, we require anhydrous AlCl3. So here again what will happen? Acyl group COCH3 group. Where will this COCH3 group come? Again this group will come in the meta position like this, sorry, ortho position like this. And yes, we get another compound. Where COCH3 group will come in the para position like this. Okay. Achha. Now you tell me, what is the name of this compound? Just this compound. If I just hide this OCH3, what is the name of this compound? I think we have discussed it now.
Acetophenone.
Very good. Acetophenone. Acetophenone. So its name would be 2-methoxyacetophenone. Its name would be 2-methoxyacetophenone. 2-methoxyacetophenone. And 4-methoxyacetophenone. Okay, so conversions might come. Okay, so these are will help us to distinguish between your phenol and alcohol. So yes, how are you going to distinguish between phenol and alcohol? Phenol gives a purple coloration when treated with neutral FeCl3 solution, but alcohols do not respond to this test. So if you wish to give the equations, then so yes, phenol is acidic in nature, so it will react with ferric chloride to give us a violet colored complex having this formula, and this complex is responsible for the color, whereas alcohols, okay, do not react with ferric chloride solution. Alcohols do not react with ferric chloride solution. Okay. Okay. Now, if the question comes, distinguish between phenol and alcohol is this. Okay. Now, distinguish between phenol and benzoic acid. I distinguish between phenol and benzoic acid. Okay. You can give this test again. Phenol will react with neutral FeCl3 solution, but benzoic acid will react, but it will give you a buff colored solution. Okay, it will give you a buff colored solution, but I will suggest you to write down this distinguishing test. By the way, what was the order of acidity among your organic compounds? Yes, what is the order of acidity? I gave you now the order. क्या था order? Which organic compound is most acidic? Remember? तुम लोग ने लिखा था. I think you guys have written it down. C greater than P greater than W greater than A. CpWA, carboxylic acid, most acidic, then phenol, then water, then alcohol. Okay, so this is the order of acidity. Now remember, benzoic acid we have not studied till yet, but remember, benzoic acid is a very strong acid among all the organic compounds. Okay, it's a very strong acid. Okay, so what happens when benzoic acid is treated with bicarbonates? What do you think will happen? Acid reacts with bicarbonate. We have done this elementary reaction. Any acid reacts with bicarbonate. It will give you salt, water, and carbon dioxide. Right? It will give you salt, water, and carbon dioxide. So what is the salt out here? C6H5. Salt now, what is the concept of salt? The acidic hydrogen will be replaced by metal. Sodium acetate, salt, we get water, and we get carbon dioxide out here. Okay, so here what is going to happen? Here you'll notice brisk effervescence of carbon dioxide or carbon dioxide gases evolved. Right? Okay, so not only benzoic acid, any carboxylic acid, it might be acetic acid, it may be formic acid, any carboxylic acid reacts with bicarbonates, and during the reaction there is a evolution of carbon dioxide. So carbon dioxide is evolved with brisk effervescence. But we know compared to benzoic acid, phenol is less acidic in reaction. Phenol is less acidic. Okay, it is less acidic than carbon. So since it is less acidic, it is not going to react with bicarbonates. It is not going to react with bicarbonates. So again, very important reaction. So by this reaction, you can distinguish between phenol and carboxylic acid. Okay, so carboxylic acid reacts with bicarbonates to give carbon dioxide gas, which is evolved with brisk effervescence. Effervescence means small bubbles. Okay, they are evolved. Whereas phenols, being less acidic, okay, they do not liberate carbon dioxide gas on treatment with here bicarbonates. Okay, okay. So now suppose distinguishing test between say ether and distinguishing test between say ether, कैसे करोगे? Any between ether and say alcohol? how are you going to distinguish between ether and alcohol now? Okay, how are we going to distinguish between ether and alcohol? Okay, so these are going to be really important, a distinguishing test. Fine. Distinguish between ether and alcohol. Yes, anyone, can you suggest me how do we distinguish between this ether and alcohol? Now, let us take an alcohol, so for example, ethyl alcohol. Okay, now what happens when ethyl alcohol reacts with sodium metal? What happens when ethyl alcohol reacts with sodium metal? Yes, tell me. What do you think will happen? Alcohols are acidic in nature. So yes, they liberate hydrogen gas. Okay, they form salt alkoxide ion. They form salt alkoxide ion. And in the process, yeah, hydrogen gas is liberated. So again, I can write out here, there is an effervescence of hydrogen gas. So there is an effervescence of hydrogen gas. Okay, so now what do you think ethers? Have we studied any acidic property of ether? No, so I'll give you an ether like this. Okay, so do you think they will react with sodium metal? No, there is going to be no reaction. There is going to be no reaction. So whenever distinguishing test का question आएगा, you have to distinguish with the help of chemical reactions like this, right? We have to distinguish with the help of chemical reactions. Okay, so most of the students, what have I noticed in this small span of teaching is how do the students distinguish? They will say distinguish between ether and alcohol. So most of the students will write down the structure of ethyl alcohol is CH3CH2H. The structure of the formula is this. No, you'll get a big zero. So whenever distinguishing test will come, you have to distinguish between a pair of compounds through a chemical reaction. You have to distinguish with the help of a chemical reaction. Okay. Now, say distinguish between, say, अब ये तो कर पाओगे. So we have done this many times. Say ethanol and propanol. Distinguish between ethanol and propanol. Yes? Someone please give me a lead. Ethanol and propanol. Have we done this distinguishing test? So not propanol, propanol. Yes, number one is a primary alcohol. Lucas test. Yes, so this will react with HCl and anhydrous ZnCl2 to form CH3, CH2Cl. And the reaction takes place after how many minutes? 15 minutes. So the reaction occurs after 15 minutes. Whereas a propan-2-ol is a secondary alcohol which is much more reactive towards Lucas reagent. Okay, so here the reaction will take place and the reaction occurs within 5 to 10 minutes. The reaction takes place within here 5 to 10 minutes. Okay, so this is how we can give the distinguishing test between here different types of alcohol. Fine. Okay, so distinguishing test is over. Yes, what is the concept of solubility? Why some compounds are soluble in water? What is the concept?
Due to polarity.
So one simple explanation which will be common, those organic compounds which can form hydrogen bonding with water will be soluble. So why are alcohols soluble in water? Alcohols are soluble in water due to the tendency to form hydrogen bonding with water, and you just saw the hydrogen bonding is So we have ROH out, and we know so we can write down the structure of alcohol in this way as well. Okay, so I'll write in this way. So I'll write R out here, ROH. Okay. Now we know because of electronegativity difference, alcohols are also polar in nature like this. Okay. So whenever we have an electronegative oxygen in close proximity with a hydrogen, then they will be attracted to each other, negative and positive. And these attraction developed is known as a hydrogen bonding. Okay. So a hydrogen bonding occurs between only a hydrogen and oxygen, or between hydrogen and nitrogen, right? So hydrogen bonding occurs only between what? Hydrogen, oxygen, hydrogen and nitrogen, or hydrogen and fluorine. Okay. So due to the formation of, what type of hydrogen bonding is this known as among different molecules? Due to the formation of, yes, intermolecular, hydrogen bonding with water. Okay, alcohols are soluble in water. So very famous question, eh? So due to the formation of intermolecular hydrogen bonding with water, alcohols are generally soluble in water. Okay. So this is not applicable only to alcohols. So remember all the organic compounds which is able to form hydrogen bonding with water. What about ethers? Do you think ethers are soluble in water? So ethers में hydrogen होता है? No. Ethers में कहाँ hydrogen होगा? ROR होता है. So ethers are not soluble in water. Why? Because they do not form hydrogen bonding with water. Simple explanation. So ethers are insoluble in water. Okay, or ethers are not soluble in water because they cannot form hydrogen bonding with water. Okay, so only those class of compounds which can form hydrogen bonding with water are soluble. They are soluble in water. Okay. So is it understood? First, what did we do? We applied simple VSEPR theory. We knew the structure of alcohol. We knew the structure of ethers. We said that this oxygen has 2 bond pair and it has 2 lone pair. That makes a total of 4 electron pair. We know according to VSEPR theory, if the total electron pair is 4, the hybridization is sp3, which leads to a tetrahedral structure, and the expected bond angle is 109.5 degree. It's tetrahedral in nature. Same about ether. Ether may be oxygen central atom. It possesses 2 lone pair, 2 bond pair. That gives a total of 4 electron pair. Again, hybridization is sp3, and we expect the bond angle to be tetrahedral. Okay. So in case of ethers, okay, the bond angle is slightly greater than that in alcohol. The bond angle in ethers is slightly greater than that in alcohol. Why? So why the bond angle in ethers is slightly greater than that in alcohol, although both are sp3 hybridized. Okay, why? There is a difference in bond angle. Yes. What should be the explanation?
Due to the repulsion of the two alkyl.
Very good. Very good. So here in case of alcohol, we have a small hydrogen atom and an alkyl group. But here we have 2 large alkyl groups. Right? So due to steric repulsion, if these groups are close to each other, they will repel each other. So to minimize this repulsion, they will just move away from each other, okay, causing a greater bond angle. So due to steric hindrance, okay, so bond angle is slightly greater than a tetrahedral due to steric repulsion between two alkyl groups. So the bond angle is slightly greater. The bond angle is slightly, so write down the bond angle is slightly greater than the tetrahedral angle, then the tetrahedral angle. Okay, why? Due to steric repulsion, between two alkyl groups. So यहाँ पर ऐसा steric repulsion कुछ है नहीं. Okay. So the bond angle is slightly greater than the tetrahedral angle due to steric repulsion between the two alkyl groups. Okay. So this is all about your physical properties. It is all about your